Good afternoon. Thank you very much for attending this talk. So today we're going to talk about non-destructive workflows for chaos physics in UE5. My name is Cedric Caillot. I'm a lead physics programmer on the chaos team. So the agenda will be, we're going to talk about the motivations of why we've developed those workflows in UE. Then we introduce Dataflow, which is the solution to that. And then we'll go through a bunch of examples, mostly focus around destruction, even though like those workflows can apply as well to other type of physics asset. And then we'll dive into a bit of how you can integrate those tools and workflows inside your pipeline. I got a future bullet point there, but there's nothing for that in my talk, so I should have removed it, sorry. Well, that's going to be Q&A, and then we can talk about the future if you want to. You can ask me the questions. So motivation behind those non-destructive workflows. So I'm pretty sure you've used non-destructive workflows before. There's many tools that exist, and some of them may be obvious to you, but I want to make sure we remind ourselves what problem we need to solve, basically. So there is iteration, there is repetition, and we can sometimes confuse one for the other. Repetition is basically, we tend, especially when you have to do a lot of assets, you tend to repeat the same operation and over, and we want to avoid that. We want to iterate to basically increase the quality of the assets. And without like non-destructive workflows, then you basically are very reliant on the source asset changes. So you do work on setting up an asset. So for example, like I'm going to tell a story about this bridge. You've certainly seen it before. It's part of the Matrix Awaken demo. And so we had an artist working on this for a long time, trying to make it like, making it look like destructively interesting. I don't know if it's a term, but yeah, it works. And then so it took a lot of time setting up like different parts of the road and making sure like they collapse on the right timing and everything. And then art basically changed the way the bridge looked. Like it was like, you know, improving the meshes and everything. And then this work has to be redone again. And that's a lot of work, and it's not a very efficient workflow. And then, so there's ways to iterate in Unreal, because you have undo redo, but undo redo only exists during your session. Once you close Unreal or it crashes, it can happen, then you have to redo everything. Also prevent exploration and discovery, because as you know, you can only move forward. You can never basically say, I'm going to try this path, you know, go down the rabbit hole of exploring, you know, this way of fracturing. Then you go back, and then if those operations are hard and hard to revert, then it doesn't incentivize you to basically explore those different ways, and then you get stuck in a maybe subpar quality, you know, otherwise that you would have like be able to achieve a different way that is more interesting. And then also like there's the problem of like as you set up those workflows, especially in physics, there's a lot of parameters that you have to enter and play with those parameters, and you have to document it along the way, but if you have to redo this asset, you better have like to take note of all those steps so that you redo it exactly the same way. Otherwise, you're going to do it differently, and then may not be the same what you wanted in the first place. The second part is like scaling with quality. So often you start with pre-production, you do a few assets to explore, you know, what you can do, and then it's time for, you know, production, very large world. You start many assets, and then you start iterating. First of all, you may have multiple artists that worked on setting up those assets, but then the problem is like they may not have the same way of setting up those assets, or they get better and better and better over time at getting those assets set up. So the first ones you've done they're okay, but now like the new ones are even better, but are you going to go back to the old ones and resetting them up again? Because it's going to be expensive and you don't have time. You want to just add new assets, basically. There's another problem, which is you set up those assets, you set up your levels, and often with physics, you end up with the level is final, then you optimize your rendering, and then physics starts showing up now in the charts of performance. And then people are like, oh, we need to have half of the number of rigid body that we should have. And then what do? You ask the artist to now edit hundreds and hundreds of assets back and to reset. It's very expensive. And often what happens, you're cut down physics or you're remove assets, and we like destruction. We want more destruction, not less destruction. So that's kind of the framework we're gonna start working from. And how do we solve that? So we implemented Dataflow, and Dataflow is kind of like a framework, and we're currently using it in lots of different physics assets. So we use it in class asset editor, which is certainly, if you have used Unreal, you're certainly the most familiar with, dealing with Dataflow. It's also in the geometry collection asset editor for destruction. The Flash asset editor, so you may not be familiar with this one. It's been used, it's more mostly used offline. So you've seen the horse in the keynote. We use this to bake simulation, and we can run the simulation for 36 hours with muscles and everything. And so it's different workflows as the other one, but it's exactly the same editor. So that's in UE 5.5. And then in UE6, we've introduced 2 new assets. So the Groom asset editor, so now you can set up your Groom asset simulation directly in Dataflow. And then the Outfit asset editor, which is a way to combine multiple class assets into a single outfit. And there will be more to come. So it's a framework, like I was saying. It's made primarily of Dataflow is an asset on its own. It's basically a graph system, an evaluation system, and it comes with editor and tools, and has some APIs, like Blueprint APIs and C++ APIs. So it's an asset. So when you have a physics asset, for example, in that case, I got a little screenshot there. You see the DF sample is the Dataflow asset, and then you get the geometry collection sample, it's its own geometry collection, and then we link the two by having the geometry collection that has a reference to the Dataflow asset and the node that it needs to use to evaluate the asset. So this way, we can use a single type of asset and use it in multiple type of physics assets. So this is the link we have. The Dataflow asset contains the main graph, the subgraphs, and the variable definition. This is the only thing it contains. It's really a recipe to create basically your asset. The integration is very straightforward. So we have an interface to implement if some of you are interested to maybe use Dataflow for your own asset. It's pretty straightforward to do. So I was saying it's a graph and a system and an evaluation system. So it's a graph as you know it, we have too many graphs in Unreal. So many graphs, I'd say so many graphs in Unreal. And then so this one is slightly different from the Blueprint graph that most of you know. It doesn't have any execution pin. So it's not like a left to right kind of reading thing. The only thing that circulates through the graph is data. And it's a pool-based evaluation, which means that's why there is a terminal node, and terminal node is named terminal, as this is what needs to generate the assets. So when this node is triggered, and I explain how this happened, it looks at its input, what is connected to its input, and will basically start pulling the data from it, and then climb up to whatever place in the graph it can go to basically fetch the data and generate the final one. The data is cached at each output of the graph, which means there's a little screenshot at the bottom that shows you. I could have been clearer on this one, but there's some performance data at the top, and some of them are red. So in that case, basically, I change a variable. They're all like a black node at the bottom, and then only basically the right side of the graph has been re-evaluated, and not the left part. So it means like if you have very expensive like part of the graph, then you don't, and if you don't touch it, you will never have to pay again for it. It will basically just re-evaluate only the thing that you change, which is nice, especially in very complex setup. So talk about everything. So sorry, just checking. And then, so it's editor and tools. And so the editor and the tools are exactly the same for all the assets. So the advantage of that is that it's, whenever we develop a new feature, whenever we improve something, we add something to it, then all the assets based on the Dataflow editor will benefit of it. So which is like a nice kind of for code maintenance and basically improvement of the tools in general. So the UI is pretty busy, and setting up those layouts are like always like tricky. So we have like a graph editor, a simulation view. So we have two 3D views. We have a simulation views and a construction view. And I'll go in detail after like about how they are used and what is their purpose. Of course, we have like asset details for your normal properties. Node details, so each node, contrary to blueprints, when you have like details for your nodes. And then you get like a collection spreadsheet, we get a scene outliner, and some Vertex painting tools, basically. So the graph editor, so very familiar. It looks and feels like your blueprint graph, and you use the same technology under the hood anyway. Like I say, no exact pin, it's only like a data connection. The concept of function is called subgraph, slightly different, but basically, yeah, rather the same. And then we have built-in output watch. So as you can see on the two node on the left, so you can right-click on a pin and basically say watch like this value, and then as the graph basically evaluates, those values will basically update in real time. And then we have like performance data on top of it, so you can identify where your graph, which part of your graph is basically performant or not. If you're looking for having like, be able to generate like asset very quickly. So the simulation viewport is like what you see is what you get is your final product. Takes the terminal node, generate the asset, and display the asset. There's a play button, a simulation button, so you can simulate as well the object right directly in Dataflow without having to go to PIE. And before, for example, especially in destruction, you'd have to put like your object inside the scene and then play PIE and then see the result and go back and then change it again. When now like everything is in one place, so which is way more convenient and easy to use. This scene is actually driven by a blueprint. So if you want to add other object in this particular scene to, because you want to be more in situ or having like effects, maybe you put like, you can listen to events to trigger some Niagara particles or something. It's up to you. You can replace these preview blueprints in the settings. So that's quite convenient. Can be used for caching as well. When, for example, you want to cache in a specific context. The construction viewport, so this is the one in Dataflow you're going to use the most. Whenever you click on a node, or you pin the node, so this is this little like pin button in the corner, the node will basically render in this viewport, but it doesn't render like with full materials and everything. It's basically just to inform you about like what is the output of this node, and then some of the debug details about it. So in that case, the plane cutter will show you final mesh when it's cut, and then the planes that basically were used to cut. So very, very nice for like debugging, when things like don't go the way you want. This window is also used for interactive painting. So if you select a node that has a tool associated with it, it will just bring the tool up. And then it looks like a bit the modeling tool. You get like a cancel and accept button, basically. We have a bunch also extra visualization. You can see the normals, the vertex IDs, and all this kind of stuff. So we're going to add more and more features as we go. And if you feel like something is needed, then please reach out to us. We'll be happy to look into it. It supports multiple views, so it's not just 3D views. It supports like 2D views, especially for the closed panel editor. For example, when you can see your closed panels, basically. UV view, so each node can decide which view it basically can display. And then so if you do a UV unwrap, for example, node, then it will display your UVs, basically. Each asset editor also has the opportunity to able to extend those views. So if you ever use Dataflow in your own, for your own asset, you're able to do lots of, extension there. Since 5.6, we've added like variable and subgraphs, so very useful for parameterization of the graph. So it looks and feel like the My Blueprint. So you have the function at the top, the variables. You can just drag a variable in the graph, and it becomes a node that you can use. Small change, small difference from blueprints. In Dataflow, you can only read a variable. You cannot set a variable. Variables are basically just more kind of like input parameters. This is how we should see them. And then we have at the bottom, we have like what we call the overrides. So the Dataflow defines a bunch of parameters and can define their defaults. And each asset that is using this Dataflow graph, because you can have like 20 assets using the same single Dataflow graph, can basically override those variables, so which is very convenient. So for example, like you have a fracture Dataflow, and then you have like, I don't know, like 3 stone asset that is using the same Dataflow, but you feel like this particular stone asset should have like maybe should be less fractured or something, then you could have like a parameter for the number of fractures, for example. We'll go in detail, I'll show an example, so it makes more sense like as we go through it. We also have we have an inspection tool. So the visual, when you click on a node, you see the debug view. It's useful, but sometimes you won't like to see actual numbers, like the data needs to be kind of more inspected in depth. So we have like a collection spreadsheet. Collection's been like geometry collection, we use it as well. Collection I use for like most of the physics asset. And then so it stores like a bunch of attributes stored inside groups, and then so you can explore all those ones by drilling it down and seeing all those data. The panel can be locked as well. You can have multiple of those, so you could look at one node and pin it, and then look at another node and pin and compare the value, and so you can do all that. So we have a Vertex attribute tool, so it's used extensively with the class asset editor, for example, where you want to paint maps and where you want your kinematic vertices and where you want like the dynamic ones or like some weight maps for how like the class stick to the normal animation or not. So like I say, it's displayed in the debug view, basically in the construction view, and then you have those little accept and cancel buttons. You can paint on your mesh, and when you accept, the data is stored basically in the node that corresponds to that. It can be chain. They can be chain as well. You can do additive or replacement. So you can have even like if you're happy with this map, but you want to paint a second map to try something, and then you don't like override the other one, you can just add another node and basically keep on adding on those ones. So this one, the nodes that do that are basically, they're not really procedural, because now if you were to change the inputs back, if we go back to like the motivation, we say, oh yeah, that'd be great to change the input mesh. And in that case, like those tools are dependent on the input mesh, so be aware that like if you change the input mesh, then those values would change, or they remap to the weird indices, because now the topology of your mesh has changed. So keep in mind, it's useful for if you have one asset, if you have a hero asset, or if you guarantee that like this Dataflow graph will be used for this one single mesh, that's useful. Or we have some tools that can do like projection of mesh from one mesh to the other as well. You can use that, and we'll add more. But it's still recommended to kind of like use more procedural way of basically defining those areas. Recently, we've added the Vertex weight tool. So this is actually, we grabbed it from the skeletal mesh editor, where you can paint like Vertex bone weights. So this way, it's like the look and feel is exactly the same, and any improvement that's done in one will be done in the other one. So trying to go in that direction, trying to avoid reinventing the wheel and making sure the tools are consistent across, different tools. I think it's important for artists in general. For now, it works so you can paint weights for bones. So you select a bone in the outliner, and then you can paint weights. I eventually would love to have like this tool to be able to do more than that. So working towards that, to be able to paint different attributes in relation to a specific selection. Ideas like this would be, would you paint, for example, attachment of a muscle, like attachment of a muscle to something else, for example, like you could do something like that. That's usually in the case of like, muscular, skeletal kind of like flesh assets. So we have API, so we have C++ API, so we have a lot of nodes. There's a map after like a screenshot that shows how many nodes we have. And then so you can write your own nodes. It's very straightforward, very easy. So if you eat a roadblock, you say, oh, I wish this node existed, then you can write your own. It's very straightforward. Like it's like writing a use struct, if you're familiar with like C++. You basically have a bunch of view properties, and you define what's like an input and output, and you define a constructor and an evaluate function, and that's it. That's really simple. So very straightforward. We also have editor extensions, so you can add menus and based on your asset as well, or like the kind of node that you select. And then we have a utility blueprint API that we've added, so you can create Dataflow assets, so you can add nodes to Dataflow assets. So you could procedurally generate Dataflow, which is a procedural basically workflow. So it's kind of like, it's quite meta in some ways. And then you can set your override variable. So you could take an asset, like a geometry collection asset, and say, I want to override those parameters. And then you can also regenerate the asset. So it's useful in pipelines where you want to just in one click, do some either variation of an asset or something like that. I'll go in detail in the pipeline integration, actually. So that's a screenshot of like, it's a node screenshot. So we have a lot of nodes. We have about like 500 available nodes as of today, and we're gonna keep adding more and more. So it's gonna grow as a library. Some nodes are very asset specific, of course. So we have like class specific asset and flash asset specific asset and node, sorry. And then, but a lot of them are basically just general. So math, collections, mesh, selection, utilities. And so feel free to explore since 5.6, the menu to select a node, to find a node is way more contextual than it used to be. So, and then we're gonna keep on like pushing to make it easier to discover new nodes or to explore like this space basically. Okay, I'm gonna go through a destruction example. Yeah, little joke, common non-destructive destruction workflow, great. Okay, so we start. Let's say we want to do concrete barriers, simple, used everywhere in every game almost. And then so we want to generate destructible recipe, kind of a uniform fracture. Want to, of course, we want the inside to look good, so we want to unwrap the UVs, have an internal materials, bake some internal texture to do some interesting material, work. Have of course, control anchoring, so they nicely anchored on the ground, and then have, of course, like a good-looking connection graph. So it's like when you destroy it, it doesn't like crumble it all at once, basically. And of course, some optimized collision. So first, we're gonna define our parameters of the graph. So we're gonna say, of course, we have many barriers. So we want the graph to work for all of them. So we're gonna put an input mesh as one of the parameters. Of course, because we're gonna have a unique internal texture that's gonna be baked, we're gonna have an internal texture. We're gonna plug in an internal material instance that's gonna come with the internal texture. We want the height of the anchoring, so we only anchor the bottom of the barrier, but just the bottom. And then so how high do we anchor it, you know? And then the number of fracture pieces, basically. So fairly straightforward, like simple. Okay, so we start with fracturing. So you have your input mesh, which is your variable. We have a first citizen kind of object that I mentioned earlier, which is called the collection. So geometry collection, I mean, it's in the name. And then, but yeah, like I say, like the other assets are basically using collection behind the scene, even though they don't always like surface it. But you see it in Dataflow basically. So you have a static mesh to collection. So now you have a collection, you can explore it with your collection spreadsheet. You can see how it's like it layouts the data with like the vertices and the faces group and everything. And then we do uniform fracture. So it's a single node that matches like your very well-known fracture editor. We have plenty of nodes. I'll go in the next slide about like how you can do that. And then as you can see, so you have the number of fractures that's plugged into the min and max Voronoi site. And then so when you click on this uniform fracture, this is what you see. You see your barrier, so like which is the default value of your input mesh. And then you can see it's like fractured, like you see all the lines basically at the edge. And yeah, I wanted to say, so right now we do a static mesh to collection, but you could do blueprint to collection, you can do geometry collection to collection, so you could build a geometry collection and then make another geometry collection out of it. So it's useful for if you do multi-platform, for example. You do your first geometry collection is like break like one level, is very crude, and then this is maybe for your low end, and then you can make for your high end, you can make another geometry collection out of it that's break like a second level basically of fracture or something else. That's an example. The blueprint to collection is very useful. I was showing to someone today, you can build very complex, put lots of mesh together, and then you turn it into a single geometry collection. It's going to go through all the static meshes and turn it into one single collection. And then we have skeletal mesh to collection that's going to basically, yeah. I don't think we ever really used it a lot. Maybe there's application for you, but it exists. And for fracture, you get Voronoi fracture. It's like the uniform fracture, but you get to add where the points are in terms of like Voronoi sites and everything. So you can be really creative, and you can even write your own scatter points or something like this if you want to. And we have a bunch of them that you can use already, like radial and uniform and grid and everything. We have a mesh cutter. We'll see an example of that, and then a plane cutter, and then a slice cutter. So, and then we'll certainly add like more and more to it. Usually the mesh cutter is extremely useful. You can be very creative with it. But yeah, sorry, I'm just going back to that. So this is in the context of destruction. Whenever you find a node in Dataflow, always try to explore if there is like variation of this node, and there's certainly a lot of stuff we've written already in the context of other assets, for example. Okay, so we're going to take care of the internal surfaces. So we have a node to say, select me the internal faces. We wrote this node, but you could also, we have a more general node that's called like select by attribute. So you can say, hey, can you select me where this attribute has this value? So you can explore your collection spreadsheet and find, and so you can do like very clever kind of like general selection without having to paint them. Basically, you can say find where all like I don't know, like the vertex position is more than this value or something. Yeah. And then so we assign the material. So we have this internal material that we want to assign. So we're going to assign it to these particular faces, and then we're going to add a UV channel and then unwrap the UVs for those particular faces. So you see, we plugged in basically the face selection. The selection is some kind of this external object that you kind of just like can pass through. And then we get that. So we get all our internal faces are now like laid out in a nice UV set. Then we can bake the texture. So in that case, we decide to bake the distance from the external surface. So that would give us like basically an information about how every pixel is, how far it is from the external faces. And then we can use it as a kind of like a way to display some form of layering inside the material, for the inside material. So the object looks as like some form of thickness. So it's more interesting than just like looking like a thin shell or something like a painted object. Then, so in that case, we had a geometry collection terminal, but in that case, we have a texture terminal, and you would say, oh, how can you have two terminals basically in the same data flow node? But we can, in that case, basically, the geometry collection terminal is going to read like the current asset you currently run on, but the texture terminal basically will basically fail if you don't pass anything, because it says, I'm in geometry collection, I'm a texture terminal, so I shouldn't do anything, and normally it does nothing. But in that case, we have an input where we can specify a specific texture to write to, and it's gonna basically write to it. So we get our texture now. Let's take out the anchoring. So on the right side, you can see we basically select by a box, and then we select those little dots are basically the actual bones of the geometry collection that we wanted to select. So the way we do it is basically we pass the collection to this function called getAnchorBounds, and then it gives us this bounding box, which is like bottom bounding box, and then we select by bounding box, which is a procedural way of selecting, as I was mentioning earlier, and then we can set the anchor state. And then so the way you do it is it's a subgraph, so it has input and outputs, a bit like functions in a blueprint. And then so we get the bounding box of the collection, we expand it to do some kind of vector mass, and based on the parameter that we had before, which is the height of the anchor, basically output like a bounding box. So it's nice, we keep our main graph like nice and neat, like we don't get all this basically noise inside the main graph, and it's like nicely done and can be reused potentially by another graph somewhere. Then we go to the connection graph. We just use a proximity node. This one has like plenty of parameters. So yeah, I didn't mention like every single node has like plenty of parameters. So play with it. You know, it's like there's a lot of stuff you can do with it. Then we're happy, we can visualize it. We say, okay, that looks well connected. And then it's time to generate like your collision. And in the past, we have like some kind of automatic generation of collision in the fracture editor tool, but they don't give you a lot of like control. And with Dataflow, you have way more fine control, because you could select like half of the object and generate like collision in one way, and then select the other one. And so you can be really inventive in the way you do it. So in that case, we say, oh, find all the leaf bones of the hierarchy and then generate like convex cells. And we generate convex cells, we simplify them because, simplified convex are faster than the more complex ones. And then now we want to generate the root collision. So in that case, we select the root bone. So there's a node for that. And then we generate the convex cell from the children hull. So we have the hulls. And now we generate like a higher level hull based on like the hulls of the children. And then we simplify it on top of this. So they give us like a very nice kind of like convex cell that we can use for games. It's going to be efficient and fast for, colliding and breaking stuff. And then the final node, so the terminal node, which is that's going to be the one that's going to be basically bake everything, not bake as cooking, but like it's going to basically take everything, all the input of the collection, and basically save it inside your geometry collection asset. There's a bunch of parameters as well, the materials and the instance meshes, because they're different. They're not stored in the collection, and so they need to be passed around. And then in the simulation view, you can then play, simulate, and you can see the result of that. And you can see, if you pay attention, you can see like the thickness, like the material making the thickness, and so all this material is basically, all this is done thanks to the texture that was like baking the distance from the surface. So it gives the impression that this object has a real inside, and it's not like this like thin shell basically. So now we got this recipe, we got this asset. So now we can start playing with it. So in that case, this little like video shows you like you can select the input mesh and change the input mesh, and you'd have to redo that all the time. It's just like you do that, you press the button. It's in the fracture editor. We basically whenever like you select like a geometry collection, that has a data flow will show the overrides basically of this asset. And then so you can select like the other mesh, and then there you go. You got like another geometry. You get this geometry collection now is like generated from this particular mesh. So it's very useful, very in situ kind of like testing. It's in your level, and it's like a one-click button. And then you can do the same for testing. So for example, like I made a little gym where like there's like this like big boulder that rolls down an artificial hill and then basically break this object. And in one case, I got like 10 fragments. The other one, I got like 100 fragments, and I can quickly just iterate and check. And when I'm happy with it, I'm saying, okay, so that's what works for this asset, and off you go. And if somebody says well, there's too many because it's too slow now, you can still go back to 50, so it's still good enough, but middle ground between performance and good-looking destruction. So I'm going to show some examples. So it's from the content example. Actually, if you grab the content example in 5.6, you'll see those stuff, and you can access the data flows, and you can explore how they've done. Artists have gone through spend time basically documenting, and there is like a comment box around it and explaining why they do this and that and how they do it. So in that case, so it's a little like this little kind of a round object, and we create like a scene shell, and then by using we take the object, we shrink it, we use a mesh cutter that cuts basically the thin shell, like the outer layer, and then we do a slice cutter for the inside, and then there is like texturing as well that happens, and so it looks this super fun kind of description. Not very usable in a game. Maybe somebody wants to make a game with like food object or something. I don't know. Yeah, that works. This one is really fun as well. It's like start from a cone, like a kind of a cone object, and then we spread points, and then we curl the points from the inside of the mesh, and then we spawn basically meshes inside, and then we turn the entire thing into a single geometry collection. And so same. It's kind of like just kind of fun, not particularly useful, but it shows you like the kind of tool you have to your, that are available to you to basically do all sort of like kind of crazy stuff. And feel free to share whenever you do something fun like this. Like feel free to share with us. Like we love this kind of stuff. Another example, like so now we start like instead of starting with like those kind of artificial meshes, we start like with a quicksand mesh, and then in that case the artist went and did some kind of like the fracture is based on the convex, so basically computing the convex, like doing convex decomposition of the object, use the convex as meshes and use them for cutting the object, and then so you can the world is yours there. You can really just go step by step and kind of like do crazy kind of combination of those things. And also like there is and then use a node that calls like a geometry script that basically kind of shrink the object from the inside and boolean it out. So it's like it makes the inside of the object like hollow. And so you can jump into those geometry script and back and change and modify something that would be extremely difficult to do in the fracture editor, because you would have to jump from one tool to the other and do those things, and now everything is like in one go. And then you could take this object and change it with another object, and then do the exact same thing, and it would just work in one click basically. And then other stuff like for example like material specific fractures. So the wall on the left, and then you can take for example like this statue, and then basically turn it into some kind of like a brick style kind of destruction. And it's basically taking the object, you find a bounding box, you spread like bricks, around this volume, and you intersect the two, and then you take the result, and there's plenty of ways you can do those things, and it's very easy. It was extremely difficult before, now it's almost like fun to do. This one is kind of interesting, like internal materials. You can see like how the wood inside is so completely procedural. Basically, the material is also very procedural, using basically based on the baked textures and everything. So how do you integrate this in your pipeline? Because that's one thing. So now you get your assets. They're all based on Dataflow. It's easy to go back and change them if you need to retune them. So you're saving a lot of time. So that's nice. And then so you can do different things. So we have a Blueprint API, which means it's automatically exposed to Python as well. So I know that a lot of people love Python. And then so in that case, I just showed a little example. We have ways to create nodes and connect nodes to make data flows. If you want to make data flow procedurally, I don't know if that's the thing, but yeah, it is possible. And then so yeah, this little like snippet, basically this is what it does. It creates a little graph on the side. The Blueprint API also allow you to do other things like setting up like overrides and everything. I'm going to show it in the next slide, and then so you can do it in Python too. So in that case, I actually made a little asset converter. So it's basically using a utility blueprint so that I have a bunch of static meshes. If I right-click on the mesh and basically select, it adds an entry in the menu, and I can basically convert to a geometry collection. And what it does is basically select the mesh, go through the mesh, and then assign the Dataflow graph, run the Dataflow graph, and then here you go, you get your meshes. And that's like one-click conversion. So on some of our projects, we had like thousands and thousands of destructible assets. And then our artists basically write like a gigantic graph that kind of try to support every kind of size and different condition that those assets are in. And basically now the artist is no longer needed. He can just move to another project or help like other stuff. And now designers they can make their source object and then turn it into a destructible without to know about destruction. So which is really useful and save a lot of time and grunt work, especially the unsatisfactory steps of setting up those things that are seems like repetitive and everything. So it's kind of solving the problem we were discussing earlier, and then focusing mostly on quality, basically. Yeah, so this is how the converter looks like. There's this get or create like a geometry collection from mesh node that effectively has more in it, but it's kind of it's more about does the asset already exist or it doesn't exist, create one or not. So it's like it doesn't have some magic in it, don't worry. But yeah, mostly what it does is get the geometry collection asset, set the data flow asset on it, override the mesh on it, override the input mesh parameter on it, and then regenerate the asset basically. And that's really what you need, 3 nodes basically. And then yeah, it scales now. You can even lately in production, somebody says, oh, we need to regenerate all those assets. You can select them all, right click, let the computer working for you, and then off you go. So yeah, so thank you. If you have any question, I'm happy to answer them.